Hey guys, Mr. Backerberg here. In this video I'm going to be going over the review sheet for test number 8. In our first few examples we're going to be taking a look at doing a bunch of graphing with some of these different trig things. So if we take a look at number 1, we're going to graph out y equals 2 sine of x plus pi over 2. What we're going to look at first is going to be that amplitude. So we're looking at our a value, which is that number in front of the sine. We've got a 2, so our amplitude for this one is going to be 2. Now when we're looking at the period, we need to look at our b value, and there is no number in front of the x, so there's like an implied 1 in front of there. So to find the period, we do 2 pi divided by the b value. So in this one, we're just going to have a period of 2 pi. Now the next thing we're going to figure out is what our first x value is that we're going to plug into our function. So we're going to take the stuff inside of the parentheses, so the x plus pi over 2, and we're going to set that equal to 0. Now we're going to end up subtracting that pi over 2 over to the right hand side. So the very first x value that we're going to plug into this function is negative pi over 2. And then to figure out the rest of those x values, we're going to look at our period, that 2 pi, and we're going to divide that into 4 equal parts. We're going to divide it by 4, and when we do that, we get a pi over 2 spacing on our x's. So our very first x value that we're going to plug in is negative pi over 2, and then we have to count up by pi over 2. So if we take negative pi over 2 and add pi over 2, we get 0. If we add pi over 2 again, then we get pi over 2. Add pi over 2 one more time and we get pi, and then one last time because we need 5 points and we end up getting 3 pi over 2. Now we need to take all of those x values and actually plug them into our function to figure out where our points are going to be. So if we plug in negative pi over 2, we should end up getting 0 as our answer. If we plug in 0, we should get 2, and then from there we can kind of use our pattern. At pi over 2 we'll be back down to 0, and then we'll hit negative 2, and then at 3 pi over 2 we'll be back to 0. So now I'm going to plot all those points, and I'm going to let each one of these dash marks represent pi over 2. So negative pi over 2 would be right here, so we're at 0. And then at 0, we're up at 2. At pi over 2, we're back down to 0. And then at pi, we're down at negative 2. And then at 3 pi over 2, we are back up to 0. So we get this to be our sine curve for number 1. Now taking a look at number 2, we've got y equals the cosine of 2x plus 1. There's no number in front of our cosine, so the amplitude is going to be 1. We do have a 2 in front of our x this time, so that's going to affect our period. So we need to take our 2 pi period divided by that b value of 2. So we end up with a period of just pi. Now as far as our starting point goes, there's nothing being added or subtracted inside of parentheses, so we're just going to start at 0. If we do what we did before, take what's inside of the parentheses and set it equal to 0, 2x equals 0, we just end up with x equals 0. So our first x value that we're plugging in is 0. And then if we take that pi period and split it into 4 equal parts, we get pi over 4 for the spacing. So our next x value is going to be pi over 4. And then if we add pi over 4 again, we'll get 2 pi over 4, which reduces down to pi over 2. And then if we add pi over 4 again, we'll get 3 pi over 4, and then one more time and we'll end up with pi. So now we need to start plugging in these x values. We do have a plus 1 on the end, so we should recognize that as a vertical shift up 1 space. But if we plug in 0, we end up getting 2. If we plug in pi over 4, we get 1. If we plug in pi over 2, we should get 0. And then at 3 pi over 4, we'll be back up at 1. And then at pi, we'll be back up at 2. So then if we plot out all of these points, we've got 0, 2. I'm going to let this dash mark represent pi over 4, so we're up at 1, then we're down to 0, then back up to 1, and back up to 2. So we've got our cosine curve that looks something like that. Now if we take a look at number 3, if we do the amplitude again, we're looking at the number out in front. We've got an amplitude of 3. We do have a b value on this one, so that'll affect our period. Since we're taking x divided by 2, the b value is really a half. So we're going to take 2 pi and divide it by 1/2. And when we do that, we should end up with a period of 4 pi. Now there's no c value in here, so if we're looking at finding the starting point, that x over 2 equals 0, we're going to end up starting at 0. So we've got 0, and then if we're looking at our spacing, we're going to take our 4 pi period and divide it by 4. So those 4's cancel out, and we end up with a spacing of pi. So our second x value is going to be pi, then we'll have 2 pi, 3 pi, and lastly we'll have 4 pi. And then we're plugging these in. So if we plug in 0 for our x, we should get 0 as our answer. If we plug in pi, we should end up getting negative 3. Plug in 2 pi, we'll be back at 0, and then 3 pi will be up at 3, and at 4 pi we should be back to 0. So then again, let's plot out all of those points. And then we'll draw in our sine curve. So it'll look something like that. Now number 4 is a little bit different because number 4 is a tangent graph. So the first thing we have to find is the left asymptote. So when we do that, we take this stuff inside of parentheses, which is x plus pi over 4, and we need to set that equal to negative pi over 2. We're going to end up subtracting that pi over 4 over to the other side, and we should end up with our left asymptote being at negative 3 pi over 4. For our right asymptote, we're going to take this stuff inside of parentheses, so again, that x plus pi over 4, but this time we're setting it equal to positive pi over 2, and then again, we'll end up subtracting that pi over 4 over to the other side, so our right asymptote will be at pi over 4. Now I'm going to have to extend this line out a little bit, and let's say negative 3 pi over 4 is that dash mark right there, so we're going to put an asymptote in there, and I'll also put an asymptote at pi over 4. Then if we're looking at plotting out our points, what we always look for next is our x-intercept, which is going to happen exactly halfway between our two asymptotes. So that's going to be right here at negative pi over 4. So that's going to be the point negative pi over 4, 0. And then we're going to look to the right of that, and that'll be 0, which we're going to plug in. So if we plug 0 in for x, we should end up getting 1 as our result. So 0, 1 is up here. And then if we look on the other side, that x value is negative pi over 2. And if we plug negative pi over 2 into our function, we should end up getting negative 1 as our answer. So we plot those out, and then we'll draw in our tangent graph. Taking a look at problem number 5, we're going to graph out 2 cosecant of x. But since this is a cosecant, I want you to ignore that for a minute and pretend this just says sine. So we're going to do all of that same amplitude and period stuff that we were doing before. So the amplitude is 2. We've got a b value of 1, so we end up with a period of 2 pi. There is no c value, so we're going to end up starting at 0. And then if we take that 2 pi period and split it into 4 parts, we end up going up by pi over 2 on our x's. So we get pi over 2 as that next x value, and then pi, and then we'll have 3 pi over 2, and then lastly we'll have 2 pi. So now we're going to plug 0 in for our x value, treating this as a sine to start with. So when we plug in 0, we should get 0. When we plug in pi over 2, we should end up getting 2 as our answer. If we plug in pi, we'll be back at 0. At 3 pi over 2, we'll be down at negative 2. And then at 2 pi, we will be back at 0. So I'm going to plot those points out. And then I'll draw in my sine curve. But remember, this sine curve wasn't our goal. We wanted to draw in a cosecant graph, so we need to make some changes to this picture. The first thing that we're going to draw in are some vertical asymptotes, and those are going to take place at the zeros of our function. So right here at 0, we'll have a vertical asymptote. At pi, we'll have a vertical asymptote. And at 2 pi, we'll have a vertical asymptote. And then we need to take these individual pieces of our graph and flip them over. So this piece on the left looks sort of like a downwards facing parabola. So if we flip that over, we'll have something that looks sort of like an upwards facing parabola. And over here we have what looks like an upwards facing parabola. So we'll flip that over and we'll get sort of a downward parabola shape for that one. So the pieces of the red graph actually represent the cosecant. Now in our next one, we're going to draw out y equals 3 secant of x, but in order to draw a secant graph, we're going to first treat it as a cosine. So we're going to do our amplitude, which is 3. There's not a b value, so the period is going to end up being 2 pi. There is no c value, so we're going to be starting at 0, and then taking that period and splitting it into 4 parts, we end up with pi over 2 for our spacing. So our second x value will be pi over 2. Our third x value will be pi. Then 3 pi over 2, and lastly 2 pi. So now plugging those in. When we plug in 0, we're going to get negative 3 as our answer. If we plug in pi over 2, we should end up getting 0. At pi, we'll be up at 3. At 3 pi over 2, we'll be back down at 0. And at 2 pi, we'll be back down at negative 3. So I'm going to plot those 5 points out. And then if we draw in our cosine graph, we get something like that. But again, the cosine graph wasn't the goal. We want to draw out a secant, so we need to make some similar changes to what we did on number 5. First thing I'm going to draw in are the asymptotes at the zeros of our function. So we've got one here, and we've got one here as well. Then if we look at flipping over the pieces of our graph, I'm going to start in the middle with this downward parabola shape. So if we flip that over, we end up with something that looks sort of like an upwards facing parabola. Now on the left-hand side, this looks sort of like an upwards facing parabola, or at least part of it. So if we flip that over and get part of a downwards facing parabola, it would look something like that. And then on the far right-hand side, we have this piece of what looks like half of an upwards parabola. So we're going to draw this left half of a downward facing parabola. And again, the red portions of the graph represent the secant that we were looking for. If we take a look at problems 7, 8, and 9, we're looking at doing some inverse trig using our unit circle. So on number 7, we're asked to evaluate the arc cosine of negative root 3 over 2. So since we're doing an arc cosine and looking at the unit circle, we should be focusing on the top half of the unit circle. This is a negative value, so I'm going to be looking in quadrant 2, and we should end up getting 5 pi over 6 as our answer for that angle. For number 8, we're looking at the inverse sine of 1/2. Inverse sine, remember, we're looking at the right half of the unit circle. This is a positive value, so I'm going to look at quadrant 1. That ends up being the angle pi over 6. And then for number 9, we're looking at the arctangent of negative root 3. So for an arctangent, we're looking at the right half. This is a negative value, so we should be looking down in the 4th quadrant. We do have to remember that our angles need to fall between pi over 2 and negative pi over 2. So when we evaluate this, we should end up getting negative pi over 3. Now with our next set of problems, I'm suggesting that maybe you draw out a picture to help you out. So on number 10, we're evaluating the cosine of the arcsine of 4/5. So when we're doing an inverse sine, we have to be on the right-hand side. And since this is positive, we have to be up in the 1st quadrant. Now, as far as our triangle goes, theta is going to be right next to the origin. The sine means that we have the opposite side and the hypotenuse. So if we use some Pythagorean triples, this other side would have to be 3. That's all we need the inside stuff for, because now this becomes the angle theta, so we have to evaluate the cosine of theta. So cosine is the adjacent side over the hypotenuse, so we should get 3/5 as our answer for that one. For number 11, we're doing the tangent of the arc cosine of negative 5/13. Arc cosine means that we need to be on the top half, and since this is negative, this is going to be a picture in the 2nd quadrant. Again, I'm going to put theta right next to the origin. Cosine means that we have the adjacent side and the hypotenuse. And since this 5 is the x value, that has to get the negative on it. Now this is also a Pythagorean triple. That opposite side should end up being 12. So we can get rid of that inside stuff and replace that with our angle theta. Now we're doing the tangent of theta, and tangent is opposite over adjacent. So we should get 12 over negative 5. Now for number 12, we're doing the cosecant of the arcsine of 7 over x. And even though we don't know what x is, or even if it's a positive or a negative number, we can still draw this out. So I'm just going to draw out an angle in the 1st quadrant, theta next to the origin. Sine is opposite over hypotenuse. We don't even need to know what the other side is. Since we're evaluating a cosecant, we've got everything that we need. So I'm going to get rid of this arcsine stuff and replace that with theta. Cosecant is hypotenuse over opposite, so we end up with x over 7. So it's just the reciprocal of that sine that we were looking at before. Now our last 2 problems are going to be word problems, and my suggestion is always going to be to draw out a picture for these. So we've got an airplane climbing at an angle of 11 degrees. So I'm going to start drawing this out. We're doing trig stuff, so we know that we have to be dealing with some sort of a right triangle. We've got this airplane traveling at an incline with an angle of 11 degrees. We want to figure out the ground distance, so the horizontal distance across the bottom that our airplane has traveled when it gets an altitude of 400 feet. So that means 400 feet in the air. So this 400 feet I'm going to label on that vertical side. Now we need to set up an equation that we can solve. We've got the opposite side from our angle and also the adjacent side. So this is going to be a tangent equation. So tangent of 11 degrees equals the opposite side 400 over the adjacent side x. Now what I'm going to do is I'm going to put this tangent over 1 and do a little cross multiplying. So we end up with 400 equals x times the tangent of 11 degrees. And then in order to get x all by itself, we're going to divide both sides by the tangent of 11 degrees. So now we need to type this into our calculator, 400 divided by tangent of 11 degrees. Remember to change your calculator into degree mode since this is a degree angle. And I'm just going to go to 1 decimal place. When we type this in, we should get 2,057.8 feet. Now on our last one, it says we are flying a kite and we let out 300 feet of string that makes an angle of 38 degrees. So let's start sketching our picture. So we're standing over here flying this kite. Again, we've got this right triangle look since we're doing trig stuff. We let out 300 feet of string, so this diagonal piece is going to represent our 300 feet. It says we've got an angle of 38 degrees with the ground, and then we want to find out how high above the ground the kite is. So we're looking for this vertical side. So again, if we start setting up an equation, we've got the opposite side and the hypotenuse, which means this has to be a sine equation. So sine of 38 equals x over 300. Now in this one, in order to get x all by itself, all we have to do is multiply both sides by 300. So then in our calculator, we should type in 300 times the sine of 38. And again, if we go to 1 decimal place, we should end up getting 184.7 feet. That's going to be it for this video. Thanks for watching.